this is my robot that I spent the last month designing and building to face Hritik RC's robot that he's made. So why are we doing all of this? Well, it all started 1 month ago. So me and Hritik were looking for a cool summer project to work on. So we sat for some hours and discussing some ideas, and then we decided to each make one robot car, and then one day we would meet up and race to find out who built the best car. I would be using Arduino while Hritik would be using Raspberry Pi to make his car robot. And then I immediately started working and planning out my robot. So my plan was for the car to be like a robot-style car, which would make it a lot easier to overcome obstacles. I'll be using materials like acrylic chassis and Lego bricks for this project. And my plan was also to keep it as lightweight as possible so that it could be really fast. I'm going to use the Arduino Uno and the L298N motor driver for this project, which are both lightweight and simple, meaning they're perfect for this project. So the first thing to do is to build the chassis itself, and then glue the Lego to the underside of the chassis. Then I attached the legs that are going to hold the motors, and then I glued them to the other Lego bricks that are already on the chassis. Then I hot glued the motors to the legs and put elastics around them to further make sure that it didn't fall off. Then after that I connected the motors to the L298N motor driver. Now it's time to do all of the electronics. I connected the motor driver to the Arduino and used a 9-volt battery as external power source for the L298N to drive my motors. And I also connected a Bluetooth module, as I will be controlling my car with my smartphone. So in the final robot, I actually ended up removing the breadboard from down here and instead just connecting a 6-volt battery directly to the small breadboard up here that is connected to the L298 and here. So as before, we have an Arduino Uno and the Bluetooth module here, and I've just tucked the cables under some other cables to make it a bit nicer, and I removed those middle legs here because I just went for a 4-wheel design as it is lightweight, and I didn't have 6 of these motors. So yeah, this is the final design. So for the code, I'm gonna keep it quite simple here. First up, I'm gonna create a variable right here, which is t. Then I'm gonna assign all of the pins that I've connected to the L298N as output, and then I'm gonna begin the serial port. Then in the loop, I'm gonna check if there's some input in the serial port, and then I'm gonna set the variable t equal to it. And then I'm also gonna print that value. Then I'm gonna check if t is equal to an f value, which is what the app will output if I press forward in the app. If that is the case, I'll digital write these pins high, resulting in all of the motors rotating in forward direction. If T is equal to G, meaning that the app sent in a G letter, which will happen when I press backwards in the app, then all of the motors will rotate in counterclockwise direction. And then the same principle for left and right. And when I press S, that is when I have pressed a button and released it. Then it's gonna send in an S, resulting in all the motors are stopped. And then I'm gonna delay that by 100 milliseconds, and then we're gonna check again and again every 100 milliseconds. So the car works beautifully now. Obviously it didn't work first try, but I just didn't have enough time to show it in this video, or this video would have been too boring.